Okay, that's pretty bad. Electricity is still not here. Interesting. Okay. All right, let's hope for the best. So, here were we? Right. So, last time we were like doing this, and if you have any questions, please do let me know. Just hold on a second, let me see if I can put it on some backup. All right, now let's hope that the backup is still there, and I'm starting now. So first of all, today, before we go further with this, I would like to introduce some rules that you got to follow. So the first thing that you need to know are the rules of significant figures. Okay. Now, yeah, okay, light is here. Okay, give me 1 second again. Sorry. Let me just. Okay. So, rules for significant figures. Right. Now, so significant figures, basically, I would like to tell you, we'll write a number here, and then we're gonna talk about number of significant figures on it, and then how do we write it in scientific notation. Okay, now please check this out, that suppose that you have a number that says 504. There's another number 540. There is another number well, let's write a couple of these just to give you an idea. Then there's a number 200, there is a number 200.0, then 0.000305 and 0.005900. So these are the numbers given. Okay. Now what you guys need to understand is that if there is a non-zero number in the start and a non-zero number at the end, it means all of these will be significant. So in this number there are 3 significant figures. In this one, this number that you see right now, the first 2 will be significant and these zeros will be non-significant because they do not have any other number than 0 afterwards. So it means this number has just 2 significant figures. Is it clear, everybody?
Yes, sir.
Now 200 is a tricky one. Although it has 2 in the first, so it can have 1 significant figure, it could be 2 significant figure, or it could be 3 significant figure. Why do I say this? Because 200, basically, if it's like a set of 200, then 300, then 400, then there is only 1 significant figure because it's recurring like that. It's a change of 100 every time. But if it is like, you see, 210, then 220, then 230, now it is 2 significant figure because 0 here does matter, right? And then if it is like 200 and then 201, 202, then this is 3 significant figures. So depends what kind of data is given. Is it clear, everybody?
Yes.
Now in case there is a point already there, and the whole thing will then become significant. If there is a point 0 at the end, it means that all these numbers matter because it's showing you the precision. Is it clear? Okay. Now if it is like 0.000, then after point 0 all the zeros are non-significant, which means only these are significant. It means it is 3 significant right here. At the end, these first 3 are non-significant figure, but if there are 2 numbers and they intentionally put 0 here, it means they want you to understand that this is significant. That means that it has 4 significant. Any questions? Please let me know.
Sir, how are the last 2 zeros significant?
Because generally you don't write, when you write 0.0059, right? Do you put extra zeros in the front?
No.
So if they have put it, it means these are significant. Is it clear?
Okay.
Now the last scientific notation. This would be written as 5.04 times 10 raised to power 2. So I've told you about how to convert this in the very first chapter. This will be 5.4 times 10 raised to power 1, 2, 3, 4. So we're ignoring the non-significant ones, right? If you're following the first significant, this will be 2 times 10 raised to power 2 only. This means this is just 1 significant figure. That's why I ignored 2 zeros. The last one, because there are 4 significant, so we're going to write 2.000 times 10 raised to power 2, because there are like 4. This one we're going to write 3.05 times 10 raised to power minus 4, and this one we're going to write 5.900 times 10 raised to power minus 3. Is it clear?
Yes, sir.
So what I mean by this is that significant figures in your answer, any number, when you write the answer, the significant figures must be there. You have to be very careful about that. Okay? Now, one of the prime examples, I want to first tell you the rule. Okay? So this is essential for not only paper 1, paper 2, but also the practical one. So it's very important. First of all, we are going to write for significant figures. So significant figures, you will always write the answer in least number of significant figure in data or one more than that. That basically tells you how to deal with this. Okay? About decimal places, you should always remember it shows the precision of the instrument. So decimal places must be the same as precision. Like I wrote it like in the previous class that if it's a ruler and you get exactly 10 centimeters, so you have to write 10.0 because then it shows the precision. Okay. Alright, just please have a look at it. I'm gonna bring some water for myself and then we're gonna continue. Okay. Now, so then let's check out an example, okay, and see what I mean by this. Suppose in a question you have two values given. So they have given you distance, which is 18.000 meters, and they have given you time, which is 28.8 seconds. Okay, like that. The moment, as also they say, calculate the speed. Okay, so it's pretty easy because when you calculate it, you write the distance over the time. You're gonna get 0.6405693950 meters per second. So that's the answer on the calculator, right? Now you're not supposed to write this answer. Why? Because this does not conform to the rule that I've told you about significant figure. Why? Because it says always write the answer in least number of significant in data or one more. So let's check it out. This one has 1, 2, 3, 4, 5 significant figures, and this one has 3 significant figures. So basically what I want to tell you is that the answer can be, this answer can be written in either 3 significant figure, so it is going to be, you can write it as 0.641 meters per second. Either this is right, or you could write it in 4 significant figure, which is one more than the minimum, so which is 0.6406 meters per second. Now you cannot go above it and you cannot go below it, because then it would not be correct. Is it clear, everybody?
Yes, sir.
Now in paper 2, most of your answer, like 90% of your answer, will be in 2 significant figure. That makes it easier for us to not forget this. But in paper 3 specifically, they would really be strict on it, and you have to always remember that when I'm writing the answer, you can calculate the whole thing, you can write it down, but in the answer space you must take care of it. Okay, now so up till now what we have done is we have actually learned about how instruments are dealt with, what are the types of errors and stuff, right? We have done this. But most importantly, whenever this happens, whenever errors are there, right, whether systematic or random, they cause some uncertainty in your answers, right? So this is the major topic that we are going to do. Now, uncertainty is generally there in almost every instrument. So there could be uncertainty in the reading, and there could be uncertainty in the measurement. Now, whenever an instrument is there, you're taking a reading on an instrument, you must always remember that uncertainty in an instrument is equal to half of least count. And you guys now know what is the least count. For example, for a ruler, the uncertainty would be 0.05 centimeter, because it has a rule of, like, it is just the least count of a ruler is 0.1 centimeter. Is it clear? Now, the uncertainty when you're taking a measurement would be equal to the least count itself. Now, this is the thing, right? So, for example, on a ruler, the uncertainty would be 0.1 centimeter, plus and minus. Plus minus means that it could be greater or smaller, so we're giving a range. Okay, now why is it that the reading is half least count, and why is it that the measurement is full least count, right? Why? Because you see, when you look at an instrument like a ruler, right, 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. Now check this out. Suppose you measuring something like this, right? So when you take the first reading and the last reading, so in this one you have 0.05 centimeter as uncertainty, and when you take another reading, you also have the same uncertainty. So basically, when you're taking measurement, it means that you have made two, or the instrument has two mistakes in it, or instrument has two amount of errors. So when you add the errors, like you add them together, so it will give you 0.1 centimeter as plus minus. Is it clear, everybody? Right. Okay, do let me know if you have any questions here before I go on. Okay. Ramin late. Why?
I'm sorry, I forgot.
That's not good. Okay, now. So, going on to the next thing then. So, you guys should basically remember that now how exactly this is about the instrument. Okay, we can read it, we can measure it, we know the least count, so we know uncertainty is half the least count, full the least count in measurement. But what if there are like number of values? Okay, so for example, there is a student takes multiple readings on a stopwatch. Okay, so he has taken multiple readings and we want to know the uncertainty, right? So his values were 3 of them, these. Okay, so they want us to find the uncertainty. So the first thing you will always do is to find the mean value. So when you find the mean value, it is pretty easy. What you do is you add them up and then you divide them by the number of reading itself. So when you do that, your answer will be 5.03 seconds. Now to find the uncertainty in your readings, basically the formula is you take the max value, the biggest one, you subtract the minimum value, and then you divide it by 2. So the maximum value is 5.05 minus 5.01 was the minimum, and when you divide by 2, your answer should be 0.02. Okay. So how do we write this then? The answer would be 5.03 plus minus 0.02 seconds. Now what does that mean? Basically, plus minus means when you add the uncertainty into it, you're gonna get 5.05 seconds, which was the highest value. So for a person like me, you have given me just the uncertainty and this, so I can actually decipher what your readings were. Like when you subtract the mean value from 0.02 from the mean value, you're going to get 0.01. So this will let me know that you had the lower limit of your readings is 5.01 and the upper limit was this one, and the median or the mean value was the 5.03. Is it clear, everybody? Any questions?
Yes, sir.
Okay, so this is how it is dealt with. Okay, now there are a couple of ways we can actually write it down as well. For example, okay, there are 3 ways of writing it. So first way is basically writing uncertainty in the absolute way. Then we can write it in fractional form. And the third thing we can do is we can write in percentage uncertainty, like that. Okay. Now, when you're looking at the absolute uncertainty, it has a simple design. Like you have the mean value like this, plus minus the uncertainty like this, right? And of course, you will have some unit or no unit, doesn't matter. The fraction is that you divide the uncertainty over the actual value like this. And percentage just means that you're gonna multiply the fraction with 100%. Is it clear, everybody? So these are like three different things. I just want to tell you that A is the mean value, whatever is the center one, and delta A is the uncertainty of the particular value. So you just need to remember, right? A typical example is just an example that 2.0 plus minus 0.1 centimeter is a form of absolute uncertainty. Fraction has no units, so you can just write 0.1 over 2.0, and then this one could be 0.1 over 2.0 times 100%, like that. Everybody understand that?
Yes.
Okay, now for uncertainty we also have certain rules that we need to follow. Let me make I want this color to be a thicker color. Wait, how do I find a thicker color? Okay, this one. So remember that the uncertainty in absolute must always be in one significant figure. There is no exception to that. Okay. And the mean value must be the same decimal places as of uncertainty. Now, if you check the example up, it's basically one significant here, and because it had one decimal place, so we also have one decimal place in the mean value. Everybody understands this?
Yes, sir.
Okay. I hope that you guys can. What the color? What kind of color is this? Okay, I want mustard. Okay, fine. And then for fractional uncertainty, remember that the uncertainty must be in minimum significant figure in data or one more. So it follows the same rule that I've told you initially. Okay. Same goes for percentage. So uncertainty must be in minimum significant figure in data or one more. Is it clear? Now suppose yes. Yes.
When do we know which one to use?
Good question. But you gotta wait for that. Okay. Okay. So you guys wanna continue the class at the same time, or you wanna come back again at 5 p.m.? What do you guys say?
Sir, what?
Like, you have another class with me at 5 p.m.
Yeah.
Pakistan. You want me to take it right now because everybody is present, or you want me to do it at that time?
You can take it now.
Everybody is okay with that? Okay, well, that's good. Now, I just want to tell you one rule, okay? And you always need to remember this. So, if Ramin, who comes late usually in the class, comes late again, so how many mistakes she has done?
Just one.
Two. Two, which means that uncertainty is the error, right? So I'm going to write this golden rule in the gold color. And you guys need to remember that uncertainty is always added up. You can learn from mistakes, but if you make mistakes again and again, they just add up, right? They are never subtracted. So this is the reason people say, okay, there's no such thing as, two wrongs do not make a right. Oh, there is a such thing, right? So two wrongs do not make a right. Two wrongs basically make two wrongs. All right. So you got to remember that no matter what happens, if there are a couple of values with errors, so when you add them up, subtract them, multiply, divide, whatever, uncertainty or the errors are always going to add up, right? So before we head on with this, I just want to write a set of data that we're going to work on, and then we're going to see basically how we deal with uncertainties. So for A, it's plus minus 0.1. Okay, I'm not writing the units right now, but you need to take care of them as well. Plus minus 0.4, 5.0 plus minus 0.2. Okay, so these are three sets of readings which are given to us. So I'm gonna copy this because we need to use them again and again. Okay, I guess everybody's here. I'm sorry the meeting ended. Now, so the first thing we're going to do is to learn how to add them. So we're going to learn addition here. So suppose in the question they've given that they find D, which is equal to A plus B plus C, like that. Okay. So when you do that, you can find the mean value first. Mean value of D would be equal to 2.0 plus 3.0 plus 5.0, which is equivalent to 10.0, like that. Okay. Like I said, uncertainty is always added up. So the uncertainty in D, which is delta D basically, will be equal to 0.1 in A plus 0.4 in B plus 0.2 in C, which comes out to be 0.7. And then I'm going to write the answer. So the answer would be 10.0 plus minus 0.7. Is it clear, everybody? So what I've really done here is that I have basically added all the uncertainties and followed this. For mean value, I've just used the equation. Now you got to check. You see this one, this guy is one significant figure, so that's correct. And this one is one decimal place according to the uncertainty. Let me write same decimal place, so my answer is correct. Okay. Now let's do subtraction. Okay, I'll do it here. Okay, so suppose now they have said find D equals to C minus A. Now what you do, you find the mean value first. It will be 5.0 minus 2.0, so this will be 3.0. Now on to the uncertainty, which is of course added up. So for C it was 0.2 plus for A it was 0.1, so it is going to be 0.3. So the answer in this would be 3.0 plus minus 0.3. Any questions? Please let me know. Now, suppose they have now given you multiplication with constants. Now check this out. So suppose they are saying, oh no, find D, which is equal to 3C plus 2A minus 3B. Now let's put our data set. Oh no, that vanished. I just need to take it again. Okay, now from this data we are going to find the mean value, which is going to be 3 times 5.0 plus 2 times 2.0 minus 3 times 3.0. So the answer exactly would be 10.0. You can also check from your calculator. What you do next is that when you're finding uncertainty, we multiply 3 with 0.2, add with 2 times 0.1, add with 3 times 0.4. So you always add it. So this will come out to be 2.0. Now, when you write the answer, you must remember that the uncertainty is always one significant figure, so you're only writing 2 here, and because there are no decimal places, so you write 10. That would be the correct answer. Is it clear?
So why won't we write 10.0 and 2.0?
Because uncertainty will always has to be in one significant figure. So, and then whatever the decimal places in uncertainty are, it should be the same in the answer, like the mean value. So because there were no decimal places, so I wrote 10. Is it clear? So that's the rule. Should remember.
Yes.
All right. Now, let's go forward, right? Now, the things get a bit harder when you have multiplications of variables, right? So let's do it here. And I want to put the data set here because we want to see it right here. Okay. So suppose they say find D which is equal to B times C. Okay, now it's multiplication of variables. Now the mean value here would be of D would be B was 3, C was 5, so we got 15.0 like that. Now in multiplication, to find uncertainty, you can't just simply add it. What you need to do is uncertainty delta D would be found using add fractional uncertainties, fractional or percentage, whatever is given or you want to do it, it doesn't really matter. So let's check. So what you're going to write is the uncertainty in D upon D will be equal to, the first variable was B, so uncertainty in B over B, the second variable was this, so add it up with delta C over C. Is it clear? So you make fractions of all the variables and then you add it. Okay. Now, because we already found D, which was 15.0, delta B was, according to our data, it is 0.4 divided by 3.0 plus C was 0.2 divided by 5.0. Please check and let me know if you have any questions what I've done. Okay, so delta D then will be equal to 0.4 over 3.0 plus 0.2 over 5.0, and this whole gets multiplied with D. So the answer to this would be exactly 2.6. So when I'm writing it in absolute terms, what do? First, I should always convert the uncertainty into one significant figure. So converting in one significant would make it 3. So we're going to round it. And because there are no decimal places, so we're just going to write 15. Is it clear, everybody?
Yes, sir.
Okay, good.
So we can't write uncertainty in decimals.
We can write, suppose it was like 0.26, then I would write 0.3. You have to write uncertainty in one significant figure. Okay, that is the rule. Do you understand?
Yes.
It has nothing to do with decimals. But the mean value must be the same decimal places as the uncertainty is. Because in this question, the uncertainty had no decimal places. That's why I converted 15.0 to just 15. Okay. Alright, this is a bit trippy, but unfortunately, what can I do? You got to learn this. Okay, now let's look at division. So suppose now they say find D equals to C upon A. So now the mean value of D would be C is 5.0 and that is 2. So this will give us 2.5 as the answer. Fine. Now the uncertainty must be written the same way. Delta D over D equals to delta C over C plus delta A upon A. So you're going to pick each variable and make a fraction and add them. So now let's put in the values. So delta D, this was 2.5. Delta C was 0.2 divided by 5.0 plus 0.1 divided by 2.0. Please check it. Let me know if you have any questions. So when you find delta D by multiplying 2.5 with the whole set, you're going to get 0.225. And now I want to write the answer. Who's going to tell me what will be the uncertainty? Aisha, Ramin, Safir, and
0.2.
only 0.2. Very good. And now because there is one decimal place and this value also has one decimal place, so we're just going to write it like this, and that would be the answer. It is pretty easy once you get hold of it and practice it a lot. Okay, should I go forward now? To the last thing in uncertainty. Okay. Now the last thing is called power. So they say find D, which is equal to C square times A cube over root of B. Now this is the equation, okay? And let's put in the set here. Okay. Now the same thing, the mean value of D would be equal to 5.0 whole square times 2.0 cube and root of 3.0, right? So just the way we do it. The answer will be 57.74. I suggest then you don't round anything before the end, okay? So keep it the same. Now to find the uncertainty, we are going to follow the same thing, but this time there is a little bit difference. Okay, so first variable is C, so delta C over C. I'm leaving gaps intentionally, so you should also leave the gaps. Delta A over A plus delta B over B. Once you've done it, you will multiply powers of each variable with fraction. What I mean by this is C has power of 2, so I'm going to multiply 2 here. A has power 3, I'm going to multiply 3. And B, under root is basically half, so I'm going to multiply half. Is it clear, everybody? Now let's put in the values. Delta D over 57.74 equals to 2 times 0.2 over 5.0 plus 3 times A was 0.1 over 2.0 plus half times 0.4 over 3.0. If you have any questions, please let me know. Now when you multiply, yeah, go on.
Yeah, quite sure I understand.
Now when you multiply 57.74 with the whole thing, basically you're gonna get 17.13. You can also check it from your calculator. It's always basically good that you guys do it. So now I'm gonna write the answer. Who's gonna tell me what do I write for uncertainty?
$17.
That would make it two significant figures, not one.
20.
20. That's correct. Is it clear? So make sure that you write it to one significant. 17 is 2. Okay, Rami?
Yes.
And now, because there are no decimal places, so I will round this off so that there are no decimal places. So 57.74 can be written as 58. And that would be the correct answer. If you have any questions, please let me know. Now, who thinks this is hard? No one? That's pretty good. I'm impressed. Okay. Now,
The significant figure part is confusing.
yeah, but with practice you will understand, okay? Don't worry. Now, I just want to basically solve certain questions with you. And these are the 3 types of questions which will come in exam. And if you basically practice them a lot, basically this question usually comes as the first question. Sometimes the second question, but mostly first question. And the total marks for this question could be around 6 to 10 marks, right? So this is very essential to learn. So I'm gonna post 3 questions. You just gotta wait. I need to take out from the exam papers. Also, I need to. Oh, yeah. Somebody should also help me with, you know. Yeah, it's fine. I'll do it on my own. interesting. Oh yeah. Okay, so this question is from, wait, I also need to write their thing. This is M2K wala question. Okay, this is 9702 21 October November 2019. This one is 9702 21 MJ19, and every year these questions come. Okay, and this one, my friends, is May June 2116 2016. Okay, now let's go with the first one. In the first question, basically they have given you an equation where t is oscillation, right? So this is basically yeah, okay, fine. Now they say that the manufacturer of spring states that the spring constant is this, with percentage uncertainty is given, and an absolute uncertainty is given for the mass. Okay, so just like we have done, they want you to find the time period. So t will be equal to 2 pi. So m is 200 times 10 raised to minus 3 divided by k is 25. Please do check if all of them are in SI units. So let's now do it. Come here, my friend. Okay, 2 pi times root of 200 times 10 raised to power minus 3 divided by 25. So this is 0.56 and 2. Yeah, so I wrote it. Pretty simple, right? Now in this question they say determine the value of t with its absolute uncertainty to an appropriate number of significant figures. Now they already say it, and you've got to remember that. Okay, so I'm going to write delta t over t equals to, the first variable is m, so delta m over m, plus the second variable is k, delta k upon k. Notice that I have completely ignored 2 pi because always, whether it's multiplication, division, or power, always ignore constants with fixed value. Okay, like numerical values, you just ignore them. Now both of them have a power of half, so I'm going to multiply half and I'm going to multiply half. Why? Because there is under root there. Okay, now what you do, write delta t over 0.562 equals to half. Mass uncertainty was 4 times 10 minus 3 divided by 200 times 10 minus 3, like that, plus half. Now interestingly, here we have just percentage. So percentage basically means that he has already done delta k upon k and multiplied by 100%. We have this only delta k, so what we can do is we can just convert this percentage into fraction. How do you convert percentage into fraction? We can just divide by 100. It will be 0.08. So we're just going to write 0.08 because this is just delta k upon k. Is it clear, everybody?
Yes.
Okay, a little bit math knowledge is required here. Okay, now 0.5 uh, 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 0.5 times 4 minus 3 and minus 3 will cancel out, so don't worry about it, plus 0.5 times 0.08. So you get this, and then you go to multiply this by 0.562. So our answer for delta t is 0.0281. So in this space, what I'm going to write is, who's going to tell me? Anyone?
Sure.
0.03. What should I write there? Up to 2 decimals, so 0.56. Is it clear? That would land us 3 marks. Now this is 21 October 2019. Let's keep on checking it. Who has row of papers? Okay. We want the mark scheme of 2019. Winter 2019 2-1. Winter 2019 2-1. Okay. I don't know which question is this. Interesting. I don't even but we'll find it. First 2 questions. Okay. Now check this out. So he first writes 0.56, right? That's fine. And then at the end you must write 0.056 plus 0.03. If you don't, you basically lose a mark. Is it clear, everybody? So that's why A levels is a bit, tricky. Not hard, but tricky. So you got to remember this. Now let's go to the next question. In case percentages are given as uncertainty, I just love this question because it really just makes things simpler. Okay, so they have given you an equation and they say use the data to calculate k. So to find k, first of all, we are going to square the whole thing. So this will be v square equals to k, p and rho. So make k the subject, so v square times rho over p. So k would be equal to, what is v? 3.3 times 10 raised to 2 whole square. What is rho? 1.29 divided by 9.9 times 10 raised to 4. I also checked that all of these are in SI units, so I don't need to convert anything. When I do that, this is gonna be 3.3 times 10 raised to power 2 and square. Okay, multiply by 1.29 divided by divided by 9.9 times 10 raised to power 4. Okay, so I'm getting 1.42 like that. Okay, now let's move forward. The next question is the same. They say calculate the value of k with the absolute uncertainty. So I'm going to write delta k over k equals to delta v over v plus delta rho over rho plus delta p over p. Now the only factor that has a basically square is v, so I'm going to put 2 here, nothing else needs it. So delta k, k was 1.42, 2 times. Now because the percentage is already given, so I just need to convert it into fraction. So for this would be 0.03, then for rho it will be 0.04, and for this one it will be 0.02. As simple as that. You don't need to, because if the percentages are given, it is your lucky day. Now let's calculate this. 2 times 0.03 plus 0.04 plus 0.02, and then multiply by 1.42. So you get delta k to be 0.1704, which can be written as 0.2, and then that should be written as 1.4. Is it clear, everybody?
Yes.
Now the last question.
Sir, that's it.
That's it?
Yeah.
Okay, now this is your homework then.
Okay.
Okay. Last question is your homework. Oh no. कोई बात नहीं. Create an S. This is not even your class.